Okay, this is my last lecture on CNNs. You all are going to continue to do more work on CNNs with your cohort lead and assistant. And what I want you to do now is open up the one we did the keras tuning on. I believe mine's called MNIST-CNN. Somehow I meant to call it MNIST-CNN tuned, but it's your most recent notebook that we did in the previous day. If you get onto the bottom, there's all this like max norm and dropout and early stopping. Okay. And then I want you to copy it. So go to File, save a copy in Drive, and you call it, if you don't have this already, I guess, MNIST CNN tuned. Okay, I'm going to keep it at the 2500 rows. And I don't want to run the model yet. I will scroll down and I can see I got a last model, a respectable but not tremendous 97.6. And I'm going to go ahead and run the cells above it. So do that, go to runtime, run before. And let's add some more items. Let's add the average pooling 2D. Okay. I want to add batch normalization. We can try. That might be it. So I want to think about like some of the things that did work well. It seemed like something that worked well was increasing the dilation rate. So I'm going to try that. Dilation rate equals 2. Definitely the average pulling 2D worked. And that could just be the thing to do, honestly, based on before. Right? Because we saw quick gains just from that. Now this model has more pieces in play, right? Like with the dropout. I hope you guys can start to appreciate kind of some of the differences here where I'm just going to try this 64, where if you're like we're trying to find a balance between, right, getting this accuracy of 100%, which we can get, and not overfitting. So things like dropout, they kind of keep it honest, you could say. And I do like the idea of adding actually another layer. I'm going to try this, add a hidden layer. And just model.add dense. I'm not going to go crazy here, like 20 maybe. Out the heck, 32. And, there's a question of should there be another dropout layer? I think so, maybe to balance it out, right? And again, you just make some like modifications with best knowledge at the time, and then you revisit it based on what you're doing. Now the learning rate, I'm just going to leave it like that. 0.001 is the default. Sometimes you can make like little changes, like, will that make a difference? I don't know. Everything else looks fine. Recall that we were getting much better scores with the lower batch size. And you may be wondering as well, what's batch normalization? Okay, so it's not something that I've used frequently, but it does, I think of it as doing like what it's designed to help do, which is normalize your batches, because it just adds some, I just think of it like this, it adds extra care into the process of, the batches, because what happens when you're like tuning the layers based on the batches, well, it seems like the batches are like the number of rows, and like that it's going to have more influence. So a batch normalization helps to kind of like smooth out that process and even it out. I'm sorry that's not the best answer, but of course you can look it up and get a better one. I'm going to wait on that though. I feel like you can do it in different places. It's something like you don't have to do it everywhere. I'm just going to run this and see what happens. Hopefully won't take too long. If it takes too long, I'm going to stop it. Okay, we can see we got 23,000 parameters. So, that's like a reasonable amount, but it's not crazy. See, this dense layer added a lot. right? Extra 12,000. So we'll see how it does. And note that we often see this where like the accuracy goes from like, say, a mediocre score. I mean, you expect about 50% like random, right? But it quickly learns, right? And we've also got on the far right, the scores on the on the test set. So this is what the early stopping is looking for. And note I've got a patience of 10 here, which is significant. I may actually lower it a little for the purpose of speed. So if these show no improvements after 10 rounds, then it's going to just go back to the best validation score. And you can see the accuracy. It's like, it's pushing up a little. I think based on these initial results, my inclination would be to go potentially bigger on the accuracy side. Now, in case you're wondering, what does he mean? How does he figure this stuff out? Well, bigger on the accuracy side would be stuff like this. It would be, hey, maybe I want to do another convolutional layer. Maybe I want to do another dense layer, right? Maybe I want to take off the dilation rate, okay? Or maybe I want to take off one of the dropouts. So you want to kind of have knowledge of what the different elements are going to do for your data here. Let's see where we're at now. Yes, the accuracy is hovering around 97, but validation is actually going up a little bit, so it's not bad. But I'm just going to like assume we're not going to do a whole lot better there, and let me think about what we can do. Okay, I like kernel constraint max norm equals max norm 3 based on before. This dilation rate I'm not sure about. I think I'm going to try it without it. And I think I'm going to keep the 64. And I say, yeah, why not? What else could I change? Yeah, maybe this is too much. Right, maybe I should do like I say too much, right, but we're going for higher, right? So, maybe, I don't know. Maybe that's not an issue, really. The learning rate could be an issue here, right? We could always go back to the default of, and you can see it actually gave a good score, right? 98.7. So that's very good. I want to do better, okay? I want the accuracy to be like more like 99. Note that the validation, it is overfitting, right? The validation score, was lower. So it's still overfitting, right? And so it's almost like we want to potentially do both here. We want to try to reduce overfitting and improve accuracy. And I think making it bigger could be the way to go here, right? Like we could add another convolution layer. And maybe we do it the max pooling first, and then we do the convolution layer. And then let's lower it to 32 and do it again, the average pooling, cutting it in half here. And I was thinking about changing the kernel size and potentially adding a stride just for the fun of it, like to mix it up a little. What if I do a kernel size of 2, dilation rate is 2? Getting a little wild there, but could be fun to try. Or in this case, you could try strides equals 2, I want to be clear too, at this point, you shouldn't necessarily make the exact same changes as I do. I say to code with me, but you should try some things a little differently, right? Like in your case, maybe try strides equal 2 and things like that. Gosh, I like to think like, are there other things? What about the batch normalization? Let's throw that in. Let me find some code where I have it back in. I'm not seeing. I think you just straight add it. We had it up on the other one. Like so, I recall too. It's not clear like where to add it. Like sometimes, oh, you want to add it here. You want to add it here. You can in effect add it anywhere, right? I think this maybe is an important spot we could try. So I build this model.add and just try batch normalization. Okay. And then just go with the defaults. So maybe try that one more place. I'm like thinking of doing it places I'm concerned about for whatever reason, right? I don't know if it's gonna. It should only help. It shouldn't hurt. It's not to say that like it can't give you a lesser score, but it doesn't mean that it's like, and keep this in mind, because the score is a little bit less, that doesn't mean it's not more representative of reality. That can be a hard thing to learn. You can think about why. So I'm going to add one more before that dense layer. And then just give it a whirl and see how it goes. All right. And you can see the number of parameters has been cut down to 14,000, right? Why cut down? Well, I think so the average pulling in there an additional time. That's cutting it in half. Okay. So it's cutting in half here, it's cutting in half again, right? And again, okay. And you know, we'll see how it does. Okay. What are the early results coming in? Yeah, accuracy is a little slow here, right? We're not in the 90s yet. So it could be that, you know, there's too much cutting in half, I think. And I did have an inclination, by the way, to try, which I didn't do here, which was to really like knock this up. I've seen people have it really big. So maybe like we go with 128 here. And the other thing is that the models can take time to learn, right? So it's totally fine. Like, and then maybe take out one of the average poolings. I somehow like it early, and maybe we don't do it here. Yeah, take out one of the dropouts too, I think, because I don't think I want to drop out flat and drop out. Like well, that looks extra. And basically so all that's happening here, this is a process where it's like the idea is simply you experiment based on knowledge and based on scores, right? So there really isn't like a one way to do this. Yeah, you can try a bunch of things and fine tune. I think it's fun. I think it's kind of fun to look at the results myself. Yeah, interesting. The validation's doing quite well. So by comparison, right? It's clearly not overfitting. So I think that's interesting. And I think I'll just try one more of these rounds with you all. And sometimes it's tricky because we're starting with a place where there's a lot going on. And it could be, by the way, that if you want to go back to the default atom, by the way, you can take that out. Sorry, comment it out. And you can just change it to atom. Or you could probably just take out the parentheses and it'll recall we were doing it like that before. Right, so maybe we're like, maybe that's not working well. We can see if the defaults do a little better. Batch size, if you remember, when we lowered the batch size, we definitely got better results here. So I think we could go with an 8. I'm just going half. And, maybe I'm getting a little less patient because I want to bring it home. So maybe I bring this down to like I don't want to intuit like a 6. Okay, so those are going to be my final changes, barring like totally unexpected results here. And by all means, you can try to take things out. Like this dilation rate's still here. Maybe that's not helping. I don't know. It did before. You change like strides. Could be fun. I changed the kernel size too. That could not be a good move. We'll see. So what do we got here? 95. So yeah, for us, that's a little under par, right? Okay. You know what? I'm taking the dilation rate out. I would, by the way, do those things more like after the fact to see, right, if it's going to bring you something. So let's try this one. We got a little more defaults going. Let's see how it rolls. How many up? 44. So we got more parameters, right? So generally speaking, it should be the case with deep learning, though it's not always, right? But generally, more speakings hopefully lead to more accuracy because there's more of an opportunity to find things. Okay. Early results, who knows? All right. And you can see the other thing too, how it's definitely tricky to put it all together. Like it just is. Yeah, I was looking, by the way, I did seeing the modifications from before on the whole data set in addition to the 2000, they weren't that different. I got like 98.7. And so we know we can always go back to like, well, hey, what got the highest score, and actually use that as the starting point, right? And I'm not even sure, was it just, I'd have to go back and look, was it just the average pooling or was it with the dilation rate? Could have just been the average pooling. So it could be that some of these things, are doing a little too much here, for lack of a better word. But you can see it's a tricky business when you put a lot of stuff together. And because we're using a smaller data set, subset, you can have more of an effect too. What do we got going on here? Yeah, it's just, this is the thing, right? You can make changes based on best knowledge. Doesn't mean you're going to get best results. So I'm not going to like belabor the point. I'm showing you guys this is the real deal. Sometimes things don't work out as you expect, but this is also how you learn. Okay, you learn by trying things. And do note that the accuracy is creeping up, As long as, see, the validation's not done, that's why it stopped. So yeah, not the best. All right, so what the heck? I'll give you guys my last, like what would I honestly do here? I would consider, you know what? I got better scores with 32, okay? And I think that was that there? I can't remember where it was. I'm going to leave the batch normalization in. This was originally 16. Maybe a third layer is not necessarily helping here because we're on a smaller data set. I don't want to ignore the dropouts completely, okay? So I think this might be overkill here. I think I'm just going to leave the dropouts in because they tend to do good in the, it's hard to know, right, with the learning rate. I think that's something you want to tweak individually. And we all remember, right, that, the other one, it did, in fact, have a batch size of 1. This is a smaller data set, so it's like, I'll go with 2. Okay? So that's my model. I'll just check the first few rounds with you and see how it does. And then what's coming up next, you're going to do this with your, data set, and then we're going to move into projects, okay? And you guys are going to share with each other because as a group, if it's like 1 or 2 of us, you can see the experts are only so good here. But for you, I know some of you are going to find ways to get really good scores here. Wow, why does this one seem like it's having a hard time? Am I missing something here? Man, not the best setup. Tricky business is deep learning, okay? And on that note too, I think a lesson that I would take going forward is when you get a good score, or like your best score, save that code in general, and then you can like copy everything in a new cell to do new code, because you can build off of the code that actually got you the best score. And you can't help but wonder here if batch normalization is causing problems. So here's what I'm going to do. I'm going to close off this lecture. I'm going to make my own adjustments, and I'll get back to you guys if I can, in fact, get something different that's over 99%. We did have something before, right? Oh, this one was not good. So there you have it. You guys, I'm confident, can find some tricks here. Keep up the good work.